Section 10, Regressions. The idea behind finding a regression is taking some discrete data points and trying to create a continuous function that approximates those data points. This is our way of taking some real-world data and trying to figure out a continuous function that will approximate this. You looked at this a little bit in Algebra 1 when you talked about finding the line of best fit. We're going to see how to use the calculator to do that, and then we're also going to try to find some other types of regressions, a quadratic regression, a trig regression. First, in your packet, take a look at example number 1, where we're told in an experiment, students are measuring the speed of an object t seconds after it's released. And we have a table of values. The first thing we need to do is store this table of values in your calculator. To do this, push the Stat button, and then select option 1, Edit. It should bring up something that looks like this. First of all, if your column headings do not say L1, L2, go back to the home screen, push Stat, and say Setup Editor. Going back to my stat edit, I already had some numbers stored in there. To clear out the numbers in your list, go up to the column heading L1 and push the clear button. I'm going to do the same thing over the column heading for L2, and those are now gone. In L1, I'm going to type my t values, 0, 1, 2, 3, 4. In L2, I'll type my s values, my speeds, 0, 11.0, 19.4, 29.2, 39.4. Next thing I'd like to do is take a look at this data. I'd like to take a look at a scatter plot of my data. To create a scatter plot, you're going to push the Stat Plot button, second y equals to get you there. Under Plots 1, I'm going to turn that plot on. I'm going to select the scatter plot option from my list of 6 options. My x values will come from that L1 list that I just created. My y values from L2. That looks good. And I'm going to use a little square for my mark. You can also use pluses or dots. I'm going to push the zoom button, and I'm going to say zoom stat to make sure all this data is easily visible in my graph. And yeah, it looks like it's forming, more or less, a slanted line. Well, the next thing we need to do is create our linear regression. The graphing calculator can do all sorts of different types of regressions. Can find the line of best fit, the parabola of best fit, the cubic function of best fit. Under Stat, under Calculate, we have a list of these different types of regressions, and the formulas are given in your packet. In this case, I want to find my linear regression, the y equals mx plus b equation of the line that goes through these points. I'm going to select option number 4, linear regression, and I'm going to push enter. What it's telling me is the equation of the line that approximates my data is y equals 9.7x plus 0.4. R squared and R squared is called the correlation coefficient, and it just tells us how good of an approximation it is. The closer that number is to 1, the better our approximation is. So since R squared is 0.9986, this line is a pretty good approximation of our data. If you're not seeing those values, what you need to do is turn the diagnostics on your calculator. To get there, push second catalog, and I want to find diagnostics, and say diagnostics on. If you run the regression again, and the R values didn't show up before, they should show up now. Just to make sure this actually is a good approximation for my data, though, I want to go to the graph, and I want to graph this thing. I could type in 9.7x plus 0.4, but actually there's another way to bring up this formula. Under the Variable menu, if you go down to Statistics, under the Equation heading, I want to select option number 1, the regression equation, and it will bring up the last regression that you calculated. Push Graph, and yeah, that line is a pretty good approximation for those points. So using the variables we were given, we didn't really have x's and y's, we had s's and t's. We'd have s equals 9.7t plus 0.4. We're asked to predict the speed after 2.5 seconds. Well, all we'd have to do there is plug in 2.5 for our t. I can actually do that directly on the graph that I see by going to second calculate, select option 1, the value. When x equals 2.5, my y value is about 24.65. So after 2.5 seconds, the speed of the object should be about 24.65 meters per second. As I mentioned before, the calculator can do other types of regressions as well. In example number 2 in your packet, we're given x values that stand for the thickness of a slab of wood and s values that stand for the strength in pounds of that slab of wood. Inputting those values into your calculator, under the Stat menu, Edit, I'm going to clear away the list that I already have, and I'm going to type in my values. My x values are 4, 6, 8, 10, 12. My y value is 2,370, 5,460, 10,310, 16,250, and 23,860. Before I go to graph this, I'm going to go to y equals and just clear away that formula I already have. My plots are already set to create a scatter plot, so I'm going to go to Zoom, Stat. And it kind of looks like half of an increasing parabola over there. We're told that we wanted a quadratic model, so I'm going to use a quadratic regression this time. Go back to the Stat menu. Under Calculate, this time I want to do a quadratic regression. And these are the values that it found. My quadratic regression would look like s equals about 180.893 x squared minus 205.786 plus 272. If I go to graph that under y equals, push variables, and I'm going to select the equation for my regression once again. Go to graph it, and again, this looks like a pretty good approximation. We saw from the r² value, it was pretty close. We're also asked to find the breaking strength when x equals 2. I can again go to second calculate. The value when x equals 2. Oh, whoops, hold on a minute. Okay, let's try that one more time. The value when x equals 2 equals... not sure why that's not working. Actually, I guess the reason the calculator's having an issue with that is because the regression's technically only valid between x equals 4 and x equals 12, between your lowest x value and your highest x value. So why don't we change that problem to when s equals 5. When x equals 5, we can find the strength, and it looks like the strength will be about 3,765.393 pounds. One final one. We're going to try to find a trig model for some temperature values. Stat, Edit. I'm going to clear away the lists that I have right now. I'm just going to deal with the temperatures in Honolulu at various months. So my months are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My temperatures in Honolulu, 80.1, 80.5, 81.6, 82.8, 84.7, 86.5, 87.5, 88.7, 88.5, 86.9, 84.1, 81.2. I'm going to clear away the function I had in there, and I'm going to zoom Stat. And this does look like part of a sine or cosine function. I'm going to go to Stat, Calculate. It only has an option for a sine regression rather than a cosine regression. I don't think this is a big deal, though, because a cosine is just a sine that's been shifted left or right a little bit. I'm going to do my sine regression. And it's found A, B, C, and D values. If I go to y equals and bring up my regression, the entire formula looks something like this. And going to graph it, yeah, it seems like a pretty good approximation for those points. You can do the one for Chicago on your own.